Welcome back to BAS 121. We're on Chapter 12. We're walking through an example of clustering. So I've opened up the colleges and universities data set, and you can see we have about 49 colleges listed here. The type, remember both of these are non-numeric data fields. And over here we've got about 5 variables, all numerical, SAT scores, etc., across the top. And what we're attempting to do is we're attempting to explore this data to put it into clusters so that we can have perhaps a highly selective college, a selective, a less selective, etc. So we're going to go up to do this. We're going to go up to our Excel Miner tool. We're going to open this guy up. And notice we get this nice toolbar. And we're going to go to clusters. And notice we get the two that we talked about in the previous video, k-means, which I'll show you how to do, and hierarchical, which we'll do on this data. So let's open this guy up. So first thing I probably should have done this ahead of time, but the first thing we need to do is select our data. So I've just selected our data. I checked this because remember I did highlight the variable names, which you probably want to do because it now tells you what these variable names are. Now, right here it's saying what selected variables do you want to do the analysis on? Well, I don't want to do it on school and type because those are non-numeric. I can select these one by one, or I can use my Shift key. Do it all at once. So there are 5 variables that I would like to cluster these colleges in terms of medium SAT scores, acceptance rates, etc. And now it's just asking me if I want to perform standard clustering, and I'll go to next. And I want to, now this is an important one, normalize the input. What the computer's asking us here is, do we want in our clustering to weight each variable, normalize it so we basically weight it the same, which in this case I think we want to do, or if I don't normalize it, it's going to weight it based on the size. So in this case of the variable, so in this case, if I don't normalize it, the expenditure, because it's a much larger number, is going to dominate the analysis, which I probably don't want. I probably want to normalize this data so I don't dominate it with the largest variable. And then the next question, so we want to normalize the data. How do we want to measure the distance between data points? Well, we mentioned we're going to use geometry. A squared plus B squared equals C squared. Now the next thing is, how do we want to measure the distance between clusters? And that'll help us pick how many clusters we want to have. I use one of the two averages. The group uses the average group. Book uses the average group linkage. So let's go ahead with that. Next, we're going to say next. Do we want to draw a demogram? Yes, we do. Do we want to show the cluster membership? And let's, just for the sake of argument, because it's an example of the book, let's do it up to 4 clusters. Because obviously clustering all the way up to one cluster doesn't do us much good, right? And then we'll say finish. And we get on a separate spreadsheet this analysis from Excel Miner. Here this navigates us. Let's go to predicted clusters, the Dendogram, the input section. So you can see here it shows us what data set we pulled, what variables, what parameters we asked for. So it reminds us what we selected. We can go right here to the predicted clusters. And here's the row ID of each college. Here's the cluster of the 4 clusters we put it in. Notice there's 4 clusters. and here it gives us the raw data. So we can now take this, we could stick it into Excel, we'd probably want to put the names on here, and we would get the 4 clusters, and we would know which colleges were in which clusters. And the last thing we might want to do is go back to our output sheet and take a look at the Dendogram. Now remember, what this is doing is this is telling us which clusters they're in, and it's clustering. We can see each stage of the clustering, and this is telling us, the length of this is telling us the distance between clusters. So you can see the distance between, we did 4 clusters, and these distances are still pretty close. So 4 clusters seems like a pretty good choice, and it's actually the choice the book gave. And we'll show you in another video where the book, how the book or how you would finalize this analysis to show it. And the way you would do that is you'd simply take this into Excel or something, and you'd probably name what these colleges are, and you'd put them into the different clusters. You could use your sort techniques to make that easy to do. But that's the hierarchical clustering. Now, if we wanted to do the k-means on this same data set, that wouldn't be difficult. We could just go up here to clustering, and we could say, do k-means for us. Okay? Now, again, we're going to have to tell it the range of the data. Okay, so we now have the range of the data, and the first row contained the headers. We'll pull over our input variables and making sure that they're numeric variables. And we would hit next. Again, we want to normalize the data. K-means is going to ask us, well, how many clusters do you want? So let's say 4. This is saying how many iterations you want. So what K-means clustering is going to do is it's going to put a midpoint, 4 midpoints, because we asked for 4 clusters, either randomly or we can select, which will be another decision. We'll have the next decision. And then it's going to go through iterations to try to minimize the distance around that center point that we picked in the 4 clusters. So we have to tell that after 10 iterations, you don't get a lot of improvement. So 10 is a good number. This option is, do we want to define the midpoint of those 4 clusters to start with, or do we want to just have the computer randomly assign 4 places to start the midpoint? I usually pick the random because I don't want to have to tell it where to start. And I use these parameters and say next. I want to be able to see all of this. So I say finish. And I get a very similar output sheet. All the data. Now I can say give me the predicted clusters. Notice I like this one a little bit better because this tells me every single college again. It puts it into one of 4 clusters. Now it also highlights which clusters it's in. It also tells me the distance it is away from the other clusters. So if I wanted to say I had a college, I don't know, East Carolina, and it was very close between highly selective and selective, it would tell me how close it was. It also tells me, the 0 tells me that this college is the midpoint or the center of cluster 1. This college is the center of cluster 4. I think college 8 is Caltech. Notice how far away it is, cluster 3 in this case, how far away it is from the other clusters. Right? You can see all of that. In fact, this is Caltech, $102,000 a year. So this gives you a lot of great information. Notice that the clusters, using the different means, we got slightly different clusters. It's not the same clusters. But those are the 2 clustering techniques in Excel Miner. Thanks.